Hi, my name is Chad Bauman. I'm an owner here at Bauman Grow Heating and Cooling, and today we're going to be going over some common HVAC terms. When it comes to buying a furnace, a boiler, or say a hanging heater in a garage, one of the primary things that you'll be looking at is the efficiency. So efficiency is how much of the gas that you're burning is actually staying inside the structure. There's standard efficiency or non-condensing, or you have condensing and high efficiency. So the higher the efficiency number, the more heat is staying inside the structure from the appliance. Anything above 85% efficiency starts to condense. So as you're burning that gas and more heat is staying in there, your exhaust gases naturally are going to be cooler. And as they cool down, that exhaust gas begins to condense and create water. Condensing gas appliances have built-in drains in them to handle all the water. A standard efficiency below 85%, the exhaust gases are a lot hotter and usually can get out of the house or the structure before it actually begins to condense during the cool down phase. As you're going through the process of buying a furnace, you may see terms such as single stage or two stage or modulating. When you size a furnace for a house, you need to size it for the coldest day of the year. When it is bitter cold outside, your furnace has to be able to maintain 70 degrees in your house. Here in West Michigan, that is 2 degrees outside. So a properly sized furnace is going to run all day long in order to maintain 70 degrees inside your house when it's 2 degrees outside. However, most of our winter is spent in the 20s, the 30s, and if it gets kind of bitter cold, in the teens. But ultimately, the furnace becomes oversized at that point. So a single stage furnace is like a light bulb. If you flip the switch, the single stage furnace turns on, it gives you everything it's got until it satisfies the thermostat call, and then it'll shut off. Two stage furnaces are designed to tackle both sides of the spectrum, where your average temperature is in the colder months as opposed to the extremes. A two stage furnace has two speeds. You have first stage and then you have second stage. So first stage is 70% capacity. The gas valve only releases 70% of the gas, the blower speed slows down to match that, and it'll run that way until a predetermined time, usually from 7 minutes up to about 14 minutes. Whenever that algorithm time hits, then the furnace naturally can assume, hey, I haven't met the set point on the thermostat, and it automatically kicks up into second stage, which is 100% capacity. And it'll run at that until the thermostat is satisfied and it shuts off. Now that we've covered two stage furnaces, let's talk about modulating furnaces. A modulating furnace typically runs from 40% capacity all the way to 100% capacity in a number of steps. So modulating furnaces are continually programming and reprogramming its algorithm based on previous run cycles in order to stretch out that run band as long as possible. Another thing you might see while you're shopping for heating and cooling equipment is communicating versus standard. Similar to a light switch where you're just bridging two contact points and all of a sudden the light turns on, we can hotwire a furnace and get it to do a lot of different things just by touching two wires together. So typically your red and your white wire will make your furnace run, your red and your green wire will make your fan run. The easy way to think about this or picture this is your thermostat is controlling a bank of switches that it's turning on and off based on the needs of the house. Communicating, on the other hand, is looking at a whole series of variables and it's telling your system how to run. All of your components are talking to each other. Your thermostat, your outdoor unit, your furnace. It's monitoring indoor temperature, indoor humidity, outdoor temperature, outdoor humidity, and now it's looking at all of these variables and it's saying, okay, furnace, I want you to run at 65% capacity right now because the outdoor temperature is cool but not cold. And at the same time, we want our humidifier to turn on and humidify for a while because our humidity is too low. So it's a constant communication between all components to try and get your house really dialed into how you want it for optimum efficiency and comfort. BTUs are defined as a British thermal unit, and 1 BTU is the amount of energy needed to heat 1 pound of water 1 degree. So British thermal units, or BTUs, are used to measure the capacity of gas burning appliances, whether that be a furnace, a boiler, hanging heater, all of that. If you're in a purchasing process and looking at air conditioners or heat pumps, you're going to see a couple of terms pop up. The most common ones are tonnage, or tons, or SEER. Tonnage is going to be capacity. So a ton of cooling is 12,000 BTUs. And so a 2-ton unit would be 24,000 BTUs of heat are getting extracted out of your house every hour in the summer months. SEER, on the other hand, is how efficiently is it extracting that heat out of your house. So seasonal energy efficiency rating is basically how many kilowatts of electricity is it taking in order to take 2 tons of heat out of your house. So the higher that SEER rating, the fewer kilowatts of electricity are required for that same amount of cooling. Similar to shopping for a car, there's a lot of different brands in the heating and cooling industry. Baumann & DeGroot currently reps Amana and Carrier products. I get asked all the time what brand that I represent is more quality. They're all very similar coming off the line as far as quality goes. Now granted, there's always nuances and there's definitely some years that are better for some manufacturers. Thank you very much for spending your time and watching this video. I really hope you picked something up out of this and this was helpful. If you're interested in learning more, you can feel free to contact us here at Baumann & DeGroot.